Hello everyone, welcome back. This is Engineer Hussein Mwasabi. So this is a continuation of our NQNS Physics exam revision. In this aspect, we'll be looking at this question that we have. So before we begin, do not forget to like and subscribe, as well as hit the notification bell icon in order to get more notification on our videos. All right, let's begin. So the question reads to say, starting from rest. So let me write data here so that we can understand what we have. So starting from rest. So whenever they say that something is starting from rest, what you should understand is that the initial velocity that we have is basically 0 meters per second. And that it's a 500 kg block. So we know that the mass of whatever that we're having, which is the block in this case, is equal to 5 kg. So we've been told that starting from rest, a 5 kg block slides 2.5 meters down a rough 30 degrees incline. So the 5 kg block is sliding down a rough 30 degrees incline. So in actual sense, this is what's going on. If we draw a schematic, so let's just have a schematic. So if we draw a schematic, we're having something like this. So let's draw it properly. Not really good drawing. So we're having a 5 kg block. So 5 kg block can be placed literally anywhere. So it can as well be here. And we know that since this is an incline, it's sliding down a 2.5 meters incline. So the distance, the incline distance, so let me just do like that so that you can see the distance I'm trying to refer to. So this is the 2.5 meters distance the block is sliding. So 2.5 meters. So this is our block. So it's sliding at an angle of 30 degrees. So the angle is placed here. So the angle most that they will always give you in question will be the bottom angle. So this is 30 degrees. So it's an incline, you expect it to have a height. So it has a height and it should also have the length. This is simply just a slant height, which is L. Let me call it slant height. So let me say S sub L. Then this is just literally the length. All right, so now they're saying the coefficient of kinetic friction between the block and the incline is given as 0.40. So here mu is equal to 0.40. So this is the kinetic, the coefficient of the kinetic friction that is being experienced between the block and the incline. All right, so this is the information that we have. All right, so I've been asked to say, determine the work done by the force of gravity. Determine the work done by the force of gravity. Okay, so for the first part of the question, what you need to understand is that work done, we know work done is equal to force times the distance, isn't it? Now, what we need to understand is that work done isn't always just the work done. When it comes to the different aspects of work that can be done by an object, we need to understand that the work done by gravity is equivalent to the potential energy created by the system in which you have in question. Therefore, the work done by gravity is equal to the force of gravity times the height. Because we know that potential energy is equal to mgh, of which we need to understand that the mg represents the weight. So it's like the weight multiplied by the height. And the weight we know is a type of force, and the force in question is the force of gravity. Therefore, we have gravity times h, which simply means the same as that. I hope it's clear. Now, with that in mind, we can now determine this work done by gravity. So work done by gravity is equal to the force of gravity, of which the force of gravity is going to be written as the weight of a system, because we know that, like I gave you the illustration there, we know that since it's mg, so saying mg h, so that you can easily understand that, of which m is the mass of the system, which is the block, which is 5, g is gravity, which is 9.8, and the height is simply basically h. So we need to determine the value of h. Now, from the schematic that we have here, we know that we have, it says data here, we've been given a side and an angle. So we have 30 degrees there, and we have basically the height. So we have that slant distance there, which is 2.5. It's a right angle, so this is the height. So given one side and an angle, we always have to concentrate on the side given and the side we've been asked to find. So the side given is the opposite, and we know this is the hypotenuse. So the side given and the side we need to find, we just have the height and the op. The adjacent is not really important, so we say we use the trig ratios. So now we only get the trig ratios that are having the sides that we need in question, which is the height and the opposite. Therefore, what we have is height, hypotenuse, and the opposite. So we have which means sine theta is equal to opposite over height, of which we know that sine of the angle 30 degrees is equal to the opposite h over the height, which is 2.5. Therefore, it means that the height is 2.5 times sine 30. Therefore, the height, if you compute this basically on your calculator, you say 2.5 times sine 30, you will get your value of 1.25 meters. And that is basically the height, the vertical height. So the work done by the force of gravity is basically the potential energy that the system will have when it is at the top, this point. So be mindful about that. So we'll say that the work done by gravity is equal to, remember, we're here, so it's mass times gravity. So the mass is 5, gravity is 9.8. You can say 9.81 or just 9.8. Okay, let's just go for 9.81, the usual, times the height, which is 1.25. So we say 5 times 9.81 times 1.25. What we're going to have is basically, remember, 5 times 9.81 times 1.25. I guess my calculator has failed me. So we'll have the value of 61. So my work done by gravity is going to be equivalent to 61.3125. Now remember, it's work, so it's done in joules, like that. But be mindful that values might come out different depending with the gravity you're using in question. If at all the question paper is telling you to say take gravity to be 9.8, just run it off to one decimal place, you'll find that maybe this side, the values after the decimal point will be different. But if at all it's 9.81 and they haven't necessarily written that you should take gravity to be something, you can always just write somewhere to say, okay, in my question, I'm taking G to be equivalent to 9.81. So this is what I'm taking as my gravity to be in my question. So this is the work done by the force of gravity on the system, which is the 5.00 kg block. All right, so we now know that the value of h is basically 1.25 meters. So let me just erase this. All right, so now the next thing we're supposed to do is now determine the work done by the friction force between the block and the incline. So for numero 2, one thing you should know is that when determining the work done by friction, you need to understand that friction, the friction force, is equal to, so let's say friction, mu times the normal force. Now, for you to determine the value of, let's say, because if we need to collect data, we know that the mu, which is the coefficient of the kinetic friction, is 0.40. But do we know what the normal force is? We don't. So we're going to draw what is known as a free body diagram. A free body diagram is simply just a representation of something that is complicated in a not so complicated type of manner. So we're having the block, so mostly it's just at an angle, an incline, so don't really have to draw everything. So we have the block there at an incline. So every time you have objects on inclines like a block, remember that we know that the forces acting on this block, we have the force of gravity, which is mg. Now what you need to understand is that always you have mg cos theta this side, and you have mg sine theta this side, mg sine theta, like that. Always remember, it will always be like this. All right, so with this in mind, we need to understand that since the object is falling in this direction, it's accelerating that direction, you need to understand that friction will be in the opposite direction. So you expect friction force to be in that direction. So that's our friction force. So let me just write it properly. Force done by friction. So the friction force is in the opposite direction. So if at all we had to create a reference frame, we can just call this our datum, which is our reference. We need to understand that this is the y and this is the x. So if at all we slanted this, we can say, okay, this is our x and this is our y. So let's take this side to be positive, this side negative, this side positive, this side negative. So that would be basically our reference. But in most cases, people would mostly just put it the opposite, where the acceleration is be the positive. So mostly just take that in consideration. Since the block is falling in this direction, we'll basically just take it to be the positive on the other direction in the x-axis. So we say, okay, positive this side and then negative the other side. Because friction is opposing, and if it's opposing, you expect the friction force to come out negative. All right, so with this in mind, let us try and determine the value of the normal force. Now, you need to understand that the normal force will always act in the opposite direction as the force of what? Gravity. Therefore, I'm having mg cos theta, so I expect my normal to be in the opposite direction as my mg cos theta, which means normal force will be in that direction. Now, whenever you draw a free body diagram, you always have to sum up the forces acting in different axes. So if I sum up the forces, I need to get some motion, isn't it? Now, in the y-axis, where the normal and the mg cos theta is acting, we don't necessarily have motion. So the kinetic diagram of this representation will not give us any motion in the y-axis. Rather, we'll say it's equal to ma. And we know if we sum up all the forces in the y, we know it's mass times acceleration in the y, of which we know acceleration in the y is 0. So sum of the forces in the y is equivalent to 0. So summing up all the forces in the y, taking where the normal is to be positive, we say n minus mg cos theta is equal to 0. And n is equal to mg cos theta. Substituting the values, we have m, which is the mass, to be 5, gravity to be 9.81, then cos theta is the angle that is literally there, which is our 30 in question. So we have cos 30, like that. If you get your calculators, punch 9.81 times cos 30, you will get your value of the normal force to be equivalent to 42. So our normal, in my case, is 42.47854606. Mostly I like to take my numbers, round it off to decimal places. So it's going to be 42.48. Normal is a force, so you expect it to be in what? newtons. So after doing that, all we're supposed to do now is to go back to the formula for the friction force. So I'm going to erase my schematic because I've already used it in this case. So what I'm trying to say is that my friction force is equal to mu k. Mu, which is the coefficient of the kinetic friction times the normal force. So friction force is equal to 0.40 times the normal force, which is basically 42.48. Now, if you take your 42.48 and multiply it by 0.40, you will basically get 16. Is it 16? You have 16 like that. Yeah, 16.992. I don't know why my calculator is dying. But anyway, the frictional force is equal to 16.99 rounded off to 2 decimal places. So that is my frictional force. Now, the question that we have is literally telling us to say, what is the work done by the frictional force between the block and the what? The incline. So basically, we'll just use normal knowledge that we understand about work. We know work is equal to, work done is equal to force times what? Distance. Now, the frictional force, if you look at the free body diagram, the frictional force is going in the opposite direction. So work done by friction is equal to negative F friction times what? The distance. Now, in this case, work done by the friction force is going to be equivalent to, now remember from what we had in our schematic, we had the height. So let me just help you so that you don't get confused. We had this. We had the height, then we had the slant distance, which is 2.5, and then the length there. When it comes to you calculating the work done by friction, always consider the slant height. Always consider the slant height. Therefore, the work done by friction is equal to negative Fr times the slant height, which is the slant length that we have. So the work done by friction is equal to negative 16.99 times the slant height, which is 2.5. Therefore, if you compute this, say 16.99 times 2.5, you basically get work done by friction to be equivalent to 42.475. Therefore, one can just say that the work done by friction is equal to 42.48. Remember, it's going to be in inches like that. So that is basically the work done by friction. Now remember, it's negative, so it's negative by a positive, so you get a negative value to be that. So expect the work done to be what? Negative. All right, so now looking at the final question that we have, it's saying calculate the final velocity at the bottom of the incline. So to calculate the final velocity at the bottom of the incline, there is a very simple formula that we use. The formula is simply, so this is numero 3. Remember, it's going to be, just always use this. Whenever they say find the final velocity at the bottom of the incline, of which the system has, or let me say the question is giving you information about the initial velocity and the like. So it's going to be the work done by friction force is equal to the kinetic energy minus the potential energy. So be mindful about that. Whenever you want to find the final velocity at the bottom of the incline, remember it's work done by friction being equal to kinetic energy minus the potential energy. Remember that. Now, the kinetic energy in question is not really the initial kinetic energy because it's at the bottom of the incline. So at the bottom of the incline, you expect the potential energy final to be 0, and the kinetic energy initial to be basically what? 0. So this is the final kinetic energy, and this here is basically the initial potential energy. So we're going to say work done by friction, of which we have calculated that already, which is minus 42.48, is equal to the kinetic energy, which is half mv squared minus the potential energy. Now, basically, the potential energy initial is equivalent to the the work done by the force of gravity. So this is going to be the work done by gravity. So if you want, you could say find the velocity at the bottom of the incline. Remember, work done by friction could also be, you can also write this, work done by friction is equal to kinetic energy final minus work done by what? Gravity. You can always use this as well, in case you feel like forgetting this. Right, then you have 2.5 v squared is equal to minus 42.48 plus 61.25. So these are the values. Now I'm basically getting the values that are mostly just basically rounded off. So I'm just going to get maybe just I'll just get 61. Okay, you can get 25. It literally just depends. But if I can recall clearly, 5.2, if you remember from the first part, I feel like that wasn't the value of the work done by the work done by the force of gravity. The work done by the force of gravity was basically 61.31. That was the work done by the force of gravity. Yeah, sorry about that. So it's going to be minus 42.48 plus 61.31. And you have 2.5 v squared being equal to 18.83 divided by 2.5 divided by 2.5. You have v squared being equal to, if I divide by 2.5, so 18.83 divided by 2.5, this will give us 7.532. Square root this side, square root that side. Expect the velocity to be equivalent to, this will give us plus or minus 2.74448943. Now, I'll consider the positive velocity in this case. Therefore, velocity final is equal to 2.74 meters per second. And this is how you go about solving this problem. All right, thanks for watching. If you have queries, you can always reach me on WhatsApp on the line 077-149-5252. Remember, slow progress is better than no progress. And let's strategize before becoming a statistic. Let's try to push for that A+.